Hello everyone, this presentation is on weather and climate and it is for grade 5 science students. Weather versus climate. Weather is what you get. It is the conditions of the atmosphere over a short period of time, and it can change within minutes or hours. Weather is what is happening outside your window right now. Climate, on the other hand, is how the atmosphere behaves over a long period of time and space. Climate is the average regional weather pattern over decades. Weather is sunshine, rain, snow, wind, and storms. It's what is going on outside right now. The weather is different at different places around the planet. In some places, it's sunny right now, while in other places, it's snowing. The science of weather is called meteorology. Meteorologists study the weather and try to predict it. Predicting the weather is not easy as there are so many factors and variables involved. The weather affects us in many ways. Day-to-day changes in weather can influence how we feel and the way we look at the world. Severe weather like tornadoes, hurricanes, and blizzards can disrupt many people's lives because of the destruction they cause. Weather doesn't just stay in one place. It moves and changes from hour to hour or day to day. Weather works like dropping a pebble in water. The ripples eventually affect water far away from where the pebble was dropped. The same happens with weather around the globe. Weather in your region will eventually affect the weather hundreds or thousands of kilometers away. For example, a snowstorm around Winnipeg, Manitoba, might eventually reach Chicago, Illinois, as it moves southeast through the U.S. There are 6 main components or parts of weather. They are temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. Together, these components describe the weather at any given time. Atmosphere. Weather on Earth is caused by heat from the sun and the movement of the air. All weather happens in the lower layer of the Earth's atmosphere, which is a layer of gases surrounding Earth. The atmosphere is divided into 5 different layers that surround the Earth. This lowest level of the planet's atmosphere is called the troposphere. The troposphere extends about 7 and 15 kilometers, 5 to 10 miles from the Earth's surface. The troposphere is thickest at the equator and much thinner at the north and south poles. Most of the dust particles in the Earth's atmosphere are found in the troposphere. Most of the water vapor in the Earth's atmosphere is found in the troposphere, which is the reason why most of the clouds in the Earth's atmosphere are also found here. The troposphere is not heated directly from the sun. Instead, the sun heats the ground and the ocean, and this heat is then radiated into the troposphere. The weather we experience on Earth, including rain, thunderstorms, lightning, wind, tornadoes, hurricanes, typhoons, and even gentle breezes, occur within the troposphere. The troposphere is made up of approximately 78% nitrogen, 21% oxygen, and 1% of other gases, which include carbon dioxide, methane, neon, krypton, argon, helium, and hydrogen. The troposphere contains approximately 99% of the water vapor in the Earth's entire atmosphere. The air in the troposphere is warmest closest to the Earth and colder at higher elevations. Temperature is a measure of the heat in the air in a given space. The Earth is heated from the sun's energy, also referred to as solar energy. This solar energy not only affects how hot or cold the air is, but is a major factor in the water cycle and in the formation of winds. Temperature is measured with thermometers. In Canada, we measure in Celsius. Some numbers to remember are: water boils at 100 degrees Celsius. Water freezes at 0 degrees Celsius. The average human body temperature is 37 degrees Celsius, and room temperature is about 20 degrees Celsius. Lines of latitude. These are imaginary lines that run across a map east to west. Lines of latitude start at 0 degrees at the equator and end at 90 degrees at the north and south poles. Everything north of the equator is known as the northern hemisphere, and everything south of the equator is known as the southern hemisphere. Countries, towns, and cities located around the equator experience hot weather throughout the year. It is because the sun remains almost directly overhead every day. The countries further from the equator get less direct sunlight, so they are cooler. The areas above the Arctic Circle and below the Arctic Circle have polar climates. That means their climate is cold all year long. The areas between the Arctic Circle and the Tropic of Cancer and the Antarctic Circle and the Tropic of Capricorn have temperate climates. That means they have warm summers and cold winters. The Earth is heated from the sun's energy. The sun is this huge mass of energy, and it's constantly emitting the energy out into space. Some of that energy actually reaches the Earth, and it reaches it through a transport means known as radiation. As a matter of fact, incoming solar radiation that we refer to as shortwave radiation passes right through the atmosphere and it reaches the Earth's surface. What happens is the Earth turns around, takes this heat energy, and releases it in the form of long-wave radiation, most of which is sensible heat, known as infrared radiation. The air around us absorbs the radiation. The sun heats the planet, but it's the planet that turns around and heats the air. This is precisely why the air closer to the Earth's surface is typically a lot warmer than the air above us. It is because the heat source of our air actually comes from the Earth. The water cycle is driven by the sun's energy. The sun warms the ocean surface and other surface water, causing liquid water to evaporate and ice to sublime, which means it turns directly from a solid to a gas. These sun-driven processes move water into the atmosphere in the form of water vapor. Over time, water vapor in the atmosphere condenses into clouds and eventually falls as precipitation, rain, or snow. When precipitation reaches the Earth's surface, it has a few options. It may evaporate again, flow over the surface, or percolate, sink down into the ground. Seasons. Two things cause the seasons to change. First, the Earth moves around the sun. Second, the Earth has a tilted axis of rotation. The Earth spins around an axis. This is an imaginary line that extends from the South Pole to the North Pole. But the Earth's axis is not vertical. It's actually tilted at an angle of 23.5 degrees. The planet is always tilted in the same direction as it orbits the sun. What does the Earth's tilted axis have to do with seasons? It means that different parts of the planet are tilted towards the sun at different times of the year. It is also why the seasons are different in different parts of the world. Not all parts of the Earth have 4 distinct seasons, but they all experience seasonal variation. Close to the North Pole and the South Pole, daylight and temperatures change with the seasons. Days are longer and temperatures are warmer in the summer than in the winter. Near the equator, days are always about 12 hours long, but these areas usually have a wet and dry season. Seasons happen at different times in different parts of the world. The tilt of the Earth doesn't change as it rotates around the sun, but the part of the planet that gets the most direct sunlight does change. The northern hemisphere is tilted away from the sun from September to March. That means the northern half of the planet doesn't get as much sunlight and heat from the sun. This causes autumn and winter. During the same months, the southern hemisphere is tilted toward the sun. This means the southern half of the planet gets spring and summer. From March to September, the northern hemisphere is tilted towards the sun. So that's when the northern half of the Earth experiences spring and summer. During the same months, the southern hemisphere experiences autumn and winter. Humidity. Humidity is the moisture in the air. The more moisture in the air means the higher the humidity. Hot air can hold more water vapor than cold air. Sometimes on warm days, the air feels moist, and that's because there's so much water vapor in the air that it can't hold any more. On these days, humidity is high. Coastal regions often have high humidity because water from the ocean evaporates and puts moisture in the air. Deserts usually have low humidity because there is little water to evaporate into the air. Absolute humidity is the greatest amount of water vapor the air could hold at a certain temperature, while relative humidity is how much actual water vapor is in the air at a certain temperature. Humidity is expressed in terms of percents. Humidity is measured with a hygrometer. Evaporation goes down when humidity goes up because there's not enough room in the air to take up any more water vapor. What makes weather change? The weather you are having right now depends on the kind of air mass that is over your area. There are 4 kinds of air masses: cold and dry, cold and wet, warm and dry, and warm and wet. When 2 masses meet, they don't mix. Instead, they form a boundary or a front. Most weather changes take place along fronts. A cold front forms when a cold air mass moves into a warm air mass. Cold fronts bring partly cloudy skies, rain, or snow. Cooler temperatures and clear skies often follow a cold front. A warm front forms when a warm air mass moves over a cold air mass. Warm fronts bring wispy clouds, light rain, or snow. The weather that follows is warm and humid.